Hello and welcome to ResearchPod. Thank you for listening and joining us today. In this episode, we will be looking at the research of Dr. Patrick Guiney, Principal Scientist at Ecotox Guiney Consulting. He is leading the first systematic review to examine whether acesulfame potassium is toxic to the environment. In recent decades, our society has become more and more preoccupied with waste. As metropolises expand and the population of the planet continues to grow, more waste needs to be managed. This includes an increase in sewage and wastewater. Having more people means more toilets and taps to flush away the various waste we produce, from bodily excretions being flushed to the cooking oils washed off from pans. It isn't surprising that the sewage contains a cocktail of chemicals that require the water to be treated at wastewater plants. Even with the modern and sophisticated sewage and water treatment systems that exist in some countries, some chemicals and pollutants can survive the treatment process. This may pose a threat to people and animals by contributing to environmental contamination. Endocrine disruptor chemicals from pharmaceuticals, pesticides and personal care products are examples of classes of chemicals suspected to be changing the reproductive sex of aquatic animals. A perhaps unexpected wastewater chemical is acesulfame potassium, also known as ACE-K. Acesulfame potassium is one of several low and no-calorie sweeteners used as a healthy alternative to sugar. Serendipitously discovered by Karl Klaus in 1967, ACE-K was approved by the US Food and Drug Administration as a food and drink sweetener in 1988. It has become a popular calorie-free alternative to sugar, perhaps because it is 200 times sweeter than sucrose. Therefore, less is needed in order to achieve the desired level of sweetness in food and beverage products. ACE-K is sold directly in Sweet 1 and Sonnet sweeteners and is used to flavour many products, including baking products, soda, fruit juices, desserts and toothpaste. In the last few decades, low and no-calorie sweeteners have become much more widely used as a less caloric alternative to sugar. Whereas sugar is absorbed at a caloric cost, ACE-K is not even absorbed by the body. Instead, ACE-K is excreted out of the body unchanged. But what if there is a price to pay for calorie-free sweetness? Low and no-calorie sweeteners have been subject of much skepticism and controversy, with a lot of discussion around the potential for negative side effects. Researchers have raised concerns about cancer, kidney disease, controlling the body's blood sugar levels, and problems with pregnancy. While US and European regulatory agencies have stated such sweeteners are safe, research has begun to identify a different potential concern with ACE-K: possible environmental problems associated with wastewater contamination. As ACE-K is not absorbed by the body, it is excreted into the toilet where it makes its way to the local sewage wastewater treatment system. Ultimately, if the wastewater treatment plant cannot biodegrade it, ACE-K can potentially enter the environment, including various water bodies. Traditionally, the life of ACE-K outside of the body has been ignored. It's only in recent years that new environmental research has begun to probe the question of environmental health. As its concentration in surface water has increased, researchers have recently grown concerned that it could be the latest in a list of potentially toxic pollutants to be manufactured by man and released into the aquatic environment. One of the consequences of it being a new research topic is that there has yet to have been a systematic review of the research into ACE-K's possible environmental impacts, and no way to discern a clear agreement on the topic. This is problematic for anyone who needs an accessible and reliable assessment on the scientific literature around ACE-K, like risk managers and policymakers who are tasked to create policy to stop environmental damage. Dr. Patrick Guiney, President of Ecotox Guiney Consulting and Adjunct Professor at the University of Wisconsin-Madison, has led the publication of a review paper on the environmental risks of ACE-K. Dr. Guiney and his team have, for the first time, collated and evaluated the totality of available relevant environmental data on ACE-K, based on reliable and pertinent data, for an environmental risk assessment from published scientific papers as well as the grey literature. They used expert scientific judgment to assess, review and integrate all of the data to form a meaningful conclusion on the predicted environmental impacts of ASK. Dr. Guiney and his colleagues began by looking to focus on surface water, referring to any natural water that has not penetrated much below the surface of the ground, which are part of the water cycle. This includes the ocean, rivers, lakes and wetlands. By carefully evaluating the scientific literature surrounding ASK's chemical structure and properties, they were able to predict where it should partition in the environment. The chemical structure of ASK lends itself to being absorbed eagerly in water. This is unsurprising, given that it has been detected in wastewater and surface water generally in the lower parts per billion range. Fortunately though, soil doesn't absorb ASK with the same enthusiasm as water, meaning it won't have a major impact on soils or river or ocean sediment beds. Furthermore, its chemical structure also shows that ASK is unable to accumulate in the bodies of aquatic organisms, and this has been confirmed in published studies. But the question remained, could ASK still be toxic to aquatic animals if its concentration in surface water exceeds a non-toxic exposure? Dr. Guiney was able to collect data from papers which had recorded the concentration of ASK within water bodies from around the world. His team also evaluated studies which determined the concentration at which ASK becomes toxic, either short-term or long-term, to a wide variety of aquatic organisms including fish and invertebrates, fish embryos, freshwater plants, as well as toxicity to domestic sludge microorganisms. Combining this data to conduct a probabilistic exposure analysis, Dr. Guiney and his collaborators found that there was currently a very low risk of aquatic organisms being exposed to a toxic concentration level of ASK. The data showed that there wasn't enough ASK in surface water to harm any of the studied aquatic organisms. Even in a worst-case scenario, the concentration of ASK would still be 3.5 orders of magnitude less than the minimum concentration of toxicity needed to cause harm. The probabilistic exposure models used in this study were USA-centric, but Dr. Guiney ensured his review had global relevance by creating an exposure index, which calculates and compares ASK concentrations in USA waters to the rest of the world. It confirmed that the ASK concentrations in the USA were similar to other parts of the world with high ASK consumption, and the findings of this review are applicable throughout the world. Another point of interest in this scientific investigation was the reported rates of biodegradability of ASK, which is the process by which organic substances are decomposed by microorganisms into simpler substances such as carbon dioxide, water and ammonia, without harming the environment. If ASK is not readily degraded either in wastewater treatment plants or in the outside environment, then it could create a long-term buildup of ASK in the water. Eventually, this buildup could reach toxic concentrations and begin harming animals. For a while, scientists were concerned by this scenario as the research was showing that ASK was not readily biodegradable. Interestingly, Dr. Guiney notes a recent shift in the literature. Studies after 2014 report that ASK is quite biodegradable in several wastewater treatment plants around the world. However, it's not fully clear as to why this is the case. The cause for this shift could be higher, more efficient operating temperatures found in some treatment plants, or the evolution and establishment of populations of new bacteria that can more easily metabolize ASK, quite literally eat it for breakfast. Regardless of the mechanism in motion, it does mean that ASK isn't at risk of a stealthy long-term build-up towards toxic concentrations. On the contrary, we might even anticipate measurable decreases in the concentration of ASK in surface waters. This has been reported in some rivers in Germany, where reductions of ASK concentrations of between 70 and 80% have been observed for the studied period of 2013 to 2016. While this preliminary ASK environmental risk assessment is encouraging, we should not assume our work is done. Researchers can still do useful work to identify the degrading enzymes in bacteria on an ASK diet and sequence their genomes to understand how it can break down ASK. There is also a need for increased efforts to isolate and characterize ASK degrading bacteria from different regions. Other issues such as the impact of sunlight on ASK degradation, is another area where there is a lack of clarity in current research. Despite these clouds within our knowledge, the broader positive messages are now apparent to everyone. ACE-K has a negligible impact on the environment, posing little threat to the aquatic life that the planet depends upon. This information, while not the headline-catching drama that often captivates the general public's interest, is equally important as we continue to evaluate the resources we consume and what that consumption leaves behind. As we continue to flush away more wastewater with an increasingly varied cornucopia of new chemical compounds, it's more important than ever to be vigilant about the professional values and applications we use when developing and describing the science of environmental risk assessment that ensure transparency, reliability, and reduction of bias related to the potential impacts of these chemicals on our wastewaters and aquatic ecosystem. It's vital that we know what we are flushing down the toilet or putting down the drains of our sinks, as well as the impact it has once it leaves our bodies and homes. That's all for this episode. Thanks for listening, and stay subscribed to ResearchPod for more of the latest science. See you again soon.